So hello everyone. In last class we have seen about the electric field, and we have seen the properties of electric field lines, and we have seen the different concepts. Now in today's class we are going to start about the basically constant electric field. First we will see we will see the concept of E effective, and then we will move to the next thing, that is a calculation of electric field due to the different geometries. Okay, so let us start. So in today's class we are going to see about the constant electric field. Before going to see about the constant electric field, if I ask you, suppose my A is constant, see, or you can say, better say, suppose E is constant, or let me give some heading now first, otherwise, because most of the student want heading, sir, what is this topic? Okay, so path, or you can say a discussion on constant electric field, because there are some of the topic, some of the questions you will get. Okay, see, my lectures you will find you will find in very structured manner. I will cover all the concepts that I promised to you, and I will cover everything, not a single topic it will be missed. Okay, just be in the lecture. Okay, so let us see. Yeah, so the first thing is, if we are talking about constant electric field, sir, then what thing we can say about the constant electric field? Sir, we can say two things. If it is a constant electric field, we can say two things. Yes, sir. What is that two things? So the first thing is that, suppose the direction is like this, and E is my constant. Why I have drawn this way? Because I have told you in the last class the property of electric field line, how to represent a uniform electric field. So if E is constant, what is E? E is defined as Q into E. Sorry, E is nothing but F by Q. Correct? Q naught, that is my E. That is my E. Correct? So from here I can say my F is equal to, so if my E is constant, can I say my F will be also constant? Yes or no? Because why? Because F is equal to Q into E. So if E is constant, F is constant. Correct? Because this is constant. Because it is constant. Correct? It is constant. So as it is constant, my F is constant, and F we know it is equal to M into A. Okay, so from here we can say my A vector is equal to QE divided by M. Okay, so from here I can say my A will be also, it will be also constant. Okay, sir, then what is a new thing? So my question is that, now if A is constant, what will be the path of the particle? Suppose I throw some charged particle in this field, then what is going to be the path? My question is this: what is going to be the path? Tell me, what is going to be the path? That is my question. If it is a constant electric field or constant acceleration, you treat it as a constant acceleration, what could be the path? Just use your common sense. In physics you need only common sense. What will be the path? What will be path? Just take it a gravity now. In gravity, suppose you take a one particle with an initial velocity 0, you drop that particle. It will, the path of the particle is what? It is a straight line. Clear? Now suppose you take another particle and you throw in this direction, upward, like this, with a velocity v0. In this case, what is the path of the particle? It will be also a straight line. Correct? It will reach a maximum height and then it will come to ground. Again it is a straight line. So from here what you understand? Whenever my velocity is parallel or anti-parallel to the gravity, because in that case, if what you have to understand, if my acceleration is constant, if someone say you acceleration is constant, so from here what you have to understand? Okay, there is a two things we have to understand from here. If my velocity, sorry, if the velocity is parallel or anti parallel to ground, if it is parallel or anti parallel to ground, then it is a straight line. That is a straight line, then the path will be straight line, correct? And any irrespective of that, any other case, then it is a parabola. Irrespective of this, any other case, any other case means if these conditions are not there, then it will be always a parabola. Parabola. Clear? It will be always a parabola. So suppose yes, yeah. So suppose now I can ask you one thing. Okay, suppose this is my field. Okay, consider it as a equal distance because it's not look but you treat it as okay. You just treat it okay. Yeah. So suppose these are the field lines, okay. E is there. Now if I ask you, suppose I have a charged particle Q, then in which direction it will move and what will be the path? Because the force will act in this direction, correct or not? QE in this direction, so it will move in a straight line. So path will be a straight line, correct? The path will be a straight line. Okay, the path will be a straight line. Suppose that is a case 1. This is my case 1. Okay, suppose I take another case. Okay, suppose this plate is positive charge, this plate is negative charge. So what is my field line? Can anyone tell what is my field line? Sorry. Yeah, what is my field line? So my field line will be in this direction, correct or not? Array, my field line obviously will be in this way, from positive to negative only, na? Yes or no? It will be from positive to negative only, sir. Yeah, it will be from positive to negative only, correct? The electric field line will be from positive to negative. So if I now, sorry, suppose now this is my suppose my origin, okay. I take a one charged particle Q having a mass m, I throw it, then what will be my path? What will my path? Here my path will be what? If I throw it here, the path will be like this only, correct or not? It will be parabolic path now, because here you will get the net force in this direction. So if I throw the particle, it will try to move downward direction. So my path will be parabolic path will be there. So here the path will be parabolic in nature. Here the path will be parabolic in nature. Try to understand this. These are very important. Okay. because here if you can see the velocity is not parallel as well as not anti-parallel, both conditions are not fulfilled here, so that's why it will be a parabolic path. Clear? Okay, so if I ask you something, let us see one case, one very important thing. If in this question only, let me ask you, if in this case only, suppose the initial velocity is v naught, okay, suppose the initial velocity, it has been thrown and at an angle of theta, everything is given, okay. So suppose I ask you what is my time, like t, total time taken from here to here, what is my total time taken? Can you say it is 2u sine theta by, sorry, it is 2u sine theta by, what is g? G is g effective. Now it is g effective. Now what is g effective? If you see, there will be two force will be in downward direction. One is mg and another one is what is QE. So what is my G effective? My G effective will be, what is the net force? Mg plus QE divided by total mass. So you will get G plus QE by M. So from here I can say my time of flight will be 2u sine theta by, that is G plus QE by M. Okay, if I ask you, sir, what is the range here? Can you tell me what is the range? What is the formula for range? Sir, it is formula for range is, sir, u square sine 2 theta by g. Okay, so just g effective. So what is u square sine 2 theta? G effective is g plus q by m. Correct. So what do you understand from here? Is it electrostatic? No, it is basically a normal class 11 physics which you have learned. What you have to simply do, you have to simply replace g by g effective and you can solve any question. I can frame any number of questions. I can ask you what is maximum height, that is u square sine square theta by g, 2g. I can ask you what is the like time of flight, what is the range. I can do anything. What is the basic concept? You have to find, simply you have to replace g by g effective. Because why we are able to do so? Because it is a constant electric field. That is why we are able to do so. We can simply replace g by g effective. So suppose I can ask you one more question, like what is this question will be, okay, yeah, let me give you one more question. Suppose let me so let the electric field line like this, okay, let the electric field line look like this, and suppose there is a string is there, okay, a string is there, and initially it was there and it having a mass m. Now initially it was there and it having a mass m, and this is my E field in this direction, correct? Okay, it has a mass m. Now what is my question? You have to find the time period of oscillation. What is the time period of oscillation? So what you have to basically do, what is the what is the formula? If it is not in place in the electric field, what is the formula? And 2 pi under root of L by G. But now what it will become? But now it will become how much? But now it is T is equal to 2 pi root over of L by G effective. Now how to calculate G effective? That is the overall thing. So there is a formula for G effective. G is equal to effective is equal to tension at mean position. Tension at mean position divided by mass. Clear? Now you tell me, where is the mean position of this particle? Okay. If the suppose this is suppose this mass is m. So where will be the mean position of this particle? It will be, suppose this is my pendulum, okay, this is like this. Now if the force is acting in this direction, somewhere its mean position will be somewhere like this, correct? Its mean position will be somewhere like this. Clear? Like it will be initially it will be here if there is no electric field. Now it will be like this. Its mean position will be like this. So you will see, sir, its mean position will be somewhere like this, correct? Somewhere like this. This angle will be theta. Okay, this is the tension T, correct? Any doubt? This will be tension T. So can I say here my force will act, how much force will act? And it has a charge also, correct? Charge Q is also there. So it will become QE force here, correct? Electric field is E. So QE force here, and in this direction there will be mg also will act. So what is my net force? My net force will be under root of QE square divided by QE square plus mg square. So that is my net force. So if you know the net force, and it will be my mean position, na? Because now it will stop in this position, not in this position. It will be stop in this position. I hope it is visible to you. No, yeah, it will stop in like this, not like this. It will be stop like this. So what is my G effective? My G effective will be how much? My G effective will be how much? My G effective, if I calculate my G effective will be, simply I have to divide by m. So it will become how much? G square plus QE by m square. Sorry, QE by m square. So my time period will be, if I have to solve this question, I will not do that much of a step. I will directly do all this thing in the mind, because it's nothing. It's simply you have to see the mean position, then you have to simply simply you have to find the net force, and then you have to simply divide. There is this is my time period, this is my new time period. Answer, simple. There is this much step is not required. Just for telling you, I am writing this much step. Otherwise, there isn't this much of steps is not required. Okay, we can go for another question also. See, if you remember, we can mix it with this also. If you remember this thing, I don't know whether you remember work energy theorem, something, circular motion. If you remember circular motion, we can sorry, 1 minute, something happened, I don't know. Yeah, so if you remember work energy theorem, suppose this is my circle. Okay, this is the circle. See, yeah, suppose this is my initial position, correct? Yeah, suppose the charge Q is there, mass m, charge Q, mass m, this is there. I will ask you, what is the minimum? What is the U minimum is required so that it will make a complete circle? It will do the complete circle. What is the formula? What is the formula? Can you tell me what is the formula? What will be the U minimum so that it can do the complete circle? Can you tell me? Can you tell me what is the formula? The formula is, if you remember, it is root 5 G into R, correct? This is the formula. But now in this case, what I am trying to say, this is the thing which you know in class 11th. This is the thing which you know in class 11th. Okay. Now I am trying to do some changes here. What are the changes? Now I can frame one more question. Na? See, what are the changes here? Suppose there is a uniform field E is there here now. Now you tell me, Now you tell me what is U minimum in this case. Now my question is that, in this case you can tell me what is U minimum? Is it possible for you to calculate? If you understand my concept, what I teach you, then you can orally tell the answer. This is a very easy question for you. If you understand the concept of G effective, you can directly tell what will be the value. Tell. root 5 r bracket g plus qe by m, correct. Yes, this will be the value, simple. G effective, two forces will act downward, simple. Here also simple, G effective, clear. So these are the some mix we can do with the constant electric field. So this type of questions can come, okay. So you I hope you are comfortable with constant electric field, and any type of question will come, you simply remember that it is nothing but a gravitation, because G is somewhat similar to G. So if the question come, you have to simply think with respect to G effective, okay. And remember, if you are not able to solve with that question, then remember that it is not electrostatic, it is your kinematics or class 11 that is weak, okay. Then it is not electrostatics, because electrostatic is only this formula and there is nothing. Then other concepts are kinematics, okay. I hope it is clear. Now let's move further. Any doubt? Okay, so now we are going to start with the electric field calculation by different geometry. So our first calculation is electric field due to the finite length wire, okay. You have to remember the formulas as well as its derivation, that is very important, by the way. You have to remember both the things. Suppose I have a finite length wire is there, okay. Suppose I have the finite length, it is not straight now, okay. Wait, yeah. Suppose, yeah, so suppose this is my suppose it is my finite length wire whose length is given, and from its perpendicular bisector, okay, this distance is suppose d, okay, and it has a charge density lambda coulomb per meter. I explain you what are the charge density, lambda, then I explain you the sigma as well as rho. I explain you all the threes, okay. Lambda coulomb per meter is given, okay. At this point I want to calculate the it is positive charge, okay. I want to calculate the electric field at this point. How to do? First you try, then I will tell you. First you have to try. It is a standard proof, you have to remember with the answer, result and everything. Just first you try, then after that I will tell. First you think how to apply it, how to calculate it. So what you have to do? You have to take the element. That is clear. That is clear, because we cannot directly apply the formula. Why? Because it is not a, it's like it is not a point charge. So from this point I am going distance y, and I am taking a small element, that is dy, correct. I am taking a small element dy, and suppose it has a charge dq, and what is dq? Dq will be given as lambda dy, correct. Lambda dx, so lambda dy. Now at this point I am joining this point with this, okay. So from this point I am going at an angle theta, and I am taking a small element that is called as a d theta, clear. So what is the diagram exactly? Let me zoom it, zoom. So you will see, what you will see, there is a one charge is there, charge particle is there, that is dq, which is equal to lambda dy, correct. And there is a small point, this is my point, and the distance between them is, some distance is there, that is not given, but yeah, this angle is theta, that is given, and this distance is d, Okay, this is the case. So if this is positive charge, this is going to repel in this direction, correct? This is my small electric field dE. So if this angle is theta, this angle will be also theta. So there will be one component dE cos theta, correct? And there will be another component dE sin theta. So I can say this is my E parallel and this is my E perpendicular, because it is perpendicular to the length of the wire, correct? Okay. Now what is dE? dE means force, that is electric field, or you can say electric. I will keep a 1 coulomb of charge here, no? Yes or no? And I will calculate the force, that is by dE. So dE is equal to, what is the force, what is dE? That is K dq into 1 coulomb by r square, that is this distance. Suppose this distance is x for now, that will be x square, correct? Till now I think everything is clear here. So what is my, this will be K dq, sorry, it will be K lambda into dy divided by x square, correct? This is my dE. Now you have to put here and you have to integrate, clear? So let us start the integration. Before that, let us start. Suppose is first we will going to calculate E parallel. What is E parallel? E parallel is defined as integration of d sin theta. Now see, dE if I put, what I will get, it is in the term of y, correct? It is in the term of y, okay. And and theta is also there, and theta is also there. So theta is also variable, because if you take the element here, the theta will be less. If you take the element here, the theta will be less. So theta is also varying, as well as the length, this y is also varying. So there are the two variables are there. So what we will do, we will do some substitution. If you see from this triangle, I can say my tan theta will be how much? That is P by B, perpendicular by base. So perpendicular, that is height is y, this height is y from here, okay, and this is d. So from here you can say my y is equal to d tan theta, correct? Differentiate on both the side, you will get dy is equal to d into sec square theta d theta, correct? Also, what is my x? X, you can say my x is, sir, this is x cos theta and this is x sin theta. So from here I can say my x will be d sec theta. My x will be d sec theta. Clear? So from here now I can write my E parallel properly. What is my E parallel? See, what is dE? K lambda into dy. With dy is this thing. So I can write K lambda, dy is d sec square theta, correct, into d theta, correct, divide by, what is my x square? This thing, that is d square sec square theta, correct, and anything else is there? No. And into sin theta, that sin theta is also there, just multiply it with the sin theta, correct? So what you will get? You will get integration K lambda, see, d sec square theta will cancel out, d will cancel out, you will get K lambda by d into sin theta into d theta, correct? Now what is the limit of theta? So it is going from where theta taking in this direction. Suppose this is my theta 1 and it is sorry, yeah, so it will go up from here to here. So from theta 1 in this direction, so basically we will go from this angle and in this direction this angle. So this is my theta 2 and this is my theta 1. So I can say my limit will be from minus theta 2 to plus theta 1, because it is in opposite direction, no? So minus theta 2. Now you integrate this, so what you will get? K lambda by d. What is the integration of sin theta? Sin theta integration is minus cos theta, so you will write cos theta 1 minus cos theta 2, so that will be minus sign, so it will become K lambda by d into cos theta 2 minus cos theta 1, correct? This is my E parallel. This formula should be remember. You have to remember this formula always, because this is very important formula. Okay, if someone asks you at any time, you can answer, you have to answer this formula because it is very important formula. I hope it is clear to you. Clear? Any doubt? So this is my E parallel. Now let us calculate E perpendicular. Okay, so my E perpendicular. So what is E perpendicular? DE cos theta integration DE cos theta. So what is DE? We have calculated K lambda into dy. What is dy? Dy is equal to d sec square theta d theta divided by d square, then sec square theta, and what is my this is cos theta. So you can say sec square theta will cancel out, dd will cancel out, so what do you, K lambda by d into cos theta into d theta. So from here, if you put the limit minus theta 2 to theta 1, K lambda d into cos theta d theta, and if you integrate, what you will get, that you will get K lambda by d into sin theta 1 plus sin theta. Correct? You have to remember this formula by heart. Okay, so what we have to know, wait, I will give the conclusion also. Okay, so that is the thing. So what is our conclusion? That is more important. Conclusion, let's see the conclusion. Suppose I have our conclusion is more important. Okay, what is the conclusion which you have to remember for a finite length wire? If suppose I have a finite length wire and suppose this point is D, suppose this point is D, and suppose I'm saying suppose this distance is D and suppose this angle is theta 1 and this angle is theta 2. What you have to understand, there will be two electric field will be there. One is E perpendicular, whose value is what? K lambda by d into sin theta 1 plus sin theta 2, and one other value is E parallel, which is in downward direction, that is defined as K lambda by d into cos theta 2 minus cos theta 1. That is a two formulas, but you should know how to apply this formula because it is not look like that. First is what is D here. Okay, D is the perpendicular, remember it is a perpendicular distance of point, which point, where you have to find the field from the wire. First thing. Second thing, what is theta 1 and theta 2? They are the angles which are measured from the perpendicular to the end of the wires in opposite sense. Wait, I will give you the example, then you will understand. In opposite sense, then you will understand these 2 points. But if you are remembering this formula, then you have to remember this thing, then you completely remember this formula. This is the conclusion. Let us apply this, what I am trying to say, let us see this. Okay, let us see this. I'm trying to say, suppose take one example, this is my wire, okay. I'm saying suppose this is a point, this distance is A, and this angle suppose given 30 degree, okay, this angle suppose is given 60 degree. So what is, first is what is my D? From here, D you can say A. What is theta 1? What is theta 1? 30 degree. What is theta 2? What is theta 2? What is theta 2? It is plus 60 or minus 60? It is plus 60 or minus 60? Theta 2 is plus 60 or minus 60? Think and tell. If you see the derivation, in derivation only we have taken the minus sign, okay, minus theta 2. So there is no need to take again minus, because in the derivation we have considered. So from here my theta 2 will be directly 60 degree. Clear? Okay, wait. Because they are taken in opposite sense, and from the end to the end of the wire. It don't look like an end of the wire. Okay, wait. In opposite sense. Clear? Any doubt? Now let's take one more example. Try to understand this, because most of the people learn this formula but they don't know how to apply this formula. If you don't know how to apply this formula, then what is the use of learning this formula? Simple. Okay, so let's take one more example, then you will understand better how to apply the formula. Let me just copy this. One more example. Yes. Suppose this is my some point, and suppose this distance is A, and suppose this angle is 30 degree. Suppose this angle is, I should give this angle or not? Wait. This is my A cos theta. Okay. Suppose this angle is 20 degree. Now you have to tell me what is my D here, what is my theta 1 here, and what is my theta 2 here. That is a good question. Yes. First, what is D? D is the perpendicular distance of the point from the line, from the wire, but there is no wire is there. So what we will do? But you can see here, sir, this is my perpendicular distance from the wire, but the wire is not there. So just extend it this wire, no? Just extend this wire for your simplicity if there is a problem. So if this is A, this will be A cos theta, and this will be A sin theta. This is A cos theta, this will be A sin theta. So what is my D? D is A cos 20 degree, correct? What is theta 1? Theta 1 is the angle, theta 1 and theta 2, they are the angle which are measured from the perpendicular to the end of the wire in opposite sense. So this is my perpendicular, from perpendicular to this end. So this will be 20 plus 30, that is 50 degree, plus 50. What is theta 2? From perpendicular to the other end, but we are measuring in upward direction. They should be in opposite sense. This first theta 1 is in this sense and theta 2 should be in this sense, then it is plus, na? But theta 2 we are taking in opposite sense. In the integration we have taken, but here we are taking in same sense. So it will become minus 20 degree. Clear? Simple. So you have to remember these 2 points, and then in this example, and then you apply the formula. This is how you have to apply the formula, then only you will get the correct answer. Otherwise you will always get a wrong answer. Okay, most of the people, they remember the formula but they don't remember how to take D, theta 1, theta 2. So they even cannot solve this question also. Okay, clear? Now in this case, in this we are going to the special cases. Now case 1. What is the case 1? Infinite, or first is semi-infinite wire. semi infinite wire. What do you mean by semi infinite wire? Means it is going to infinity in one length, and at another, this is my starting point, okay, but end point is at infinity, and at this point, suppose this is my point is D, and at this point I want to find my electric field. So what is my theta 1? My theta 1 will be how much? What is my theta 1? Theta 1 will be how much? What is my theta 1? Theta 1 will be almost 90 degree, correct? What is my theta 2? Theta 2 will be 0 degree. So what is my E perpendicular? First, what is E perpendicular? Let me write it somewhere else. 0 degree, correct? Okay. So what is my, so here we will get E perpendicular and E parallel. What is my E perpendicular? Tell me. What is my E perpendicular? K lambda by D sin theta 1 plus sin theta 2 divided by sin theta 1 plus sin theta 2. So what is sin theta 1? Theta 1 is 90, theta 2 is 0, so it will become K lambda by D, correct? What is my E parallel? E parallel is cos theta 2. Cos theta 2 is 1 and cos theta 1 is 0. So that means it will again become K lambda by D. So you will get net field in this direction, correct? And what is the value of net field? Net field will be root 2 K lambda by D. This thing you have to remember, okay? So for a semi-infinite wire, the net electric field will be root 2 K lambda by D, correct? Next case, this is my first case. Next case will be infinite wire. Infinite wire. Just try to understand, there is nothing like infinite wire, okay? Suppose if my length of the wire is 1 meter and the point at which I am asking to calculate the electric field is 1 mm. What I am trying to say, suppose this length is 1 meter and suppose this distance is 1 mm. So for this point, this length will be almost very much like very big na. So here can we apply the infinite wire concept? Yes, it will look like, it will behave as an infinite wire because this theta will be almost 90. This theta will be almost 90. So that is what, if my length of the wire, this you can apply if my length of wire is greater, far greater than D. Okay, that then it is valid, then it is also valid. So in this case, what is going to be the thing? See, suppose this is my wire and it is going to infinity in this direction also, in this direction also, and suppose I want to find at this point, suppose this point is D and I want to find the electric field at this point. So what is my E perpendicular? E perpendicular you will get 2K lambda by D, and by E parallel will be 0. Okay, and what is my theta 1? Theta 1 you can see from here, it is 90 and theta 2 is also 90. So that is why my E perpendicular is this and E parallel will be 0. Clear? Any doubt till now here? Anyone have a doubt? So your picture should be very much clear about the finite wire as well as infinite wire and semi-infinite wire. Clear? This is the complete picture. Anyone have a doubt? Please ask me. I give you 10 seconds, 20 seconds. You please, if anyone have a doubt, please ask me. Otherwise, we will proceed, or we will move further. No doubt? Okay. So can we move? Yes. So let's see the next case. Next case we can see on the axis of the ring. Yeah. Electric field. Next case, electric field on the axis of ring. Okay, what I am trying to say, okay, that this is my ring. Suppose this is like, it is like this, it is like this, it is a ring, and from the center at this point I want to calculate the electric field. Try to imagine, this is my ring. Okay, from the center at distance x I want to calculate the electric field at this point. Means from the center, means what I am trying to say, you have to understand properly. From the center, okay, suppose this distance is x, I want to calculate the field at this point. So what I will do, I will keep a 1 coulomb of charge at this point and calculate the force, that will be my E field, correct? So what is the concept? Suppose here will be what? Here will be sigma, lambda or rho. Sigma, lambda or rho. It will be lambda because it is length. I am just testing whether you are attentive in the class or not. Okay, so that is lambda coulomb per meter. Okay, now, okay, so can we apply directly the formula? Answer is no. Why? Because point charge. So what you have to do, you have to go from here and you have to, what you have to do, from theta you will get, from theta to take a small element d theta, and whose length will be dx, and the charge on this will be dq, which is defined as lambda dx, correct? Correct only, na? That is small element dx, and charge will be lambda dx. So if you see, the picture is now look like this. Sorry, now you can, see like it is look like this. Okay, there is a, this angle is theta, so the field will be in this direction, correct? D. So from here we will get d cos theta. Okay, this is also theta, this is d sin theta, correct? Okay, so and radius is also given. Okay, treat the radius as r otherwise. Okay, so what is this distance? If this is r, this is x, so what is this distance? This is distance will be root over of r plus x square. So can you write my dE? My dE will be how much? My dE will be how much? K, q, q is how much? dq, dq is lambda dx divided by, what is the distance? That is x square plus r square, correct? Any doubt is there till here? No doubt. So can you tell me logically which will become 0? dE cos theta will become 0 or dE sin theta will become 0? So if you will see, I have taken an element here, so I am getting dE cos theta and dE sin theta. If I take element here, I will get dE cos dE like this. So we have a dE cos theta and dE sin theta. So you can say my vertical component will get cancelled out, only my horizontal component will be added. So I can directly say, I will there is no need to integrate this thing, okay, because this will automatically will become 0, because if you take the because of the symmetricity. So I will directly say, I will get my E net. So as by symmetry, if you want I can calculate also, but we can logically see, na, by symmetry, that is what the physics. By symmetry, my d sin theta is 0. So E net is in along the axis. E net is also along the axis. So what is my E net? That is integration of d cos theta. Sorry. Now just integrate this. What is d? D is defined as, what is d value is given? Yeah, d value is given, that is k lambda into dx divided by x square plus r square. What is cos theta? Cos theta, if you can write from here, what is cos theta? That is x upon x square plus r square power 1 by 2. So from here you will get, that is take every constant everything out, X is constant or variable? X is constant, because this distance is remains same. Whether you will take any element, this distance is always same. You will take x also out, so you will get x square plus r square to the power 3 by 2 integration 1 minute integration dx. So what is the limit of x? X from 0 to 2 pi. What is the length? 2 pi r, correct? Okay, so this will become k lambda into 2 pi r into x divided by x square plus r square to the power 3 by 2. So my E net, which is along the axis, along the axis is equal to how much? K lambda into x into 2 pi r upon x square plus r square to the power 3 by 2. Let's make it more easier, because this formulas look very difficult to remember. Suppose the total charge is on this is capital Q. The total charge on the ring is capital Q. So how I can make more easier to remember? See, lambda is what? Charge per unit length, 2 pi r. So you can replace Q is equal to lambda into 2 pi r, correct? So my final E net formula will be how much? My E net will be defined as what is? That is k q x upon x square r square to the power 3 by 2. That is a thing you have to remember. Okay, that is a thing which you have to remember. So if that is the electric field along the axis. So if suppose I have a ring, If suppose I have a ring, and this is the axis of the ring, okay, and suppose the radius is r, suppose the radius of the ring is r, then you can see from here, in this direction the net electric field will be in this direction, and here also what is the direction of net electric field? It will be in same direction, or it is in the opposite direction? By common sense you tell me. It will be in this direction, obviously. So that means from here we can say what? Here the electric field is in this direction, and here the electric field in this direction. So can we say at some point the electric field will become 0? Then only the direction can change, na? Because at one point the electric field has to become 0. So what is that point? So that point is center. Okay, so E at center, if you will see at center of the ring, you will get 0. Put x is equal to 0. For center x is equal to 0, na, just put it, you will get E net is equal to 0. Yes or no? So at center you will get my electric field as 0. So here if I draw my electric field versus x, the graph is look like this, and this graph have asked so much time, so you just remember this graph, that is very important. Graph, what is the graph? The graph is very simple. Okay, it should look like a smooth here. That is E field versus x. The center you can see my E is 0, and there is a some point we are getting maxima. Okay, this point is, if you will calculate, you will get r by root 2, and this point is minus r by root 2. At this point my E field is maximum. And what is the maximum value? How to calculate the maximum value E max? Just put x is equal to r by 2 in this equation. You will get the maximum value of E field. Okay, clear? Now we can see what we have learned, it is correct. Why? Because in this, the direction is this direction we have taken positive and this direction we have taken negative. So here it is in downward direction, it is in upward direction. At center we are getting 0. At infinity we will also get 0, because at when x is tends to infinity, this denominator dominates and this value will become 0. So at infinity we are also getting 0. At minus infinity we will again get 0. So at somewhere it has to be maximum, and that maximum value, that maximum point of maxima is x is equal to r by root 2. And what is the maximum value? You just put x is equal to r by root 2 in this equation, you can calculate what is the maximum value. Clear? So this thing you have to remember, this is the electric field due to the ring. At center 0, and everything we have discussed, whatever the condition. And how to calculate this point of maxima? Just differentiate it and put it equal to 0. Maxima minima that you have learned in mathematics, just differentiate and put it equal to 0, you will get this x is equal to plus minus root 2 r by root 2 the value. Clear? Any doubt is there? Any doubt is there? See, this is with ring having a plus q charge. Okay, so with ring having a minus q charge, what is the condition? Just flip it, simple, just flip it. Okay, any doubt till here? Anyone? Please tell me. Okay, so can we move to one example? Then after that we will end this class. Just do one example. Sorry, let's take one example. Yeah. Suppose there is a rod, okay, or we can take we can do like this. See here, suppose there is a ring. Yeah, suppose there is a ring. Suppose there is a ring and this is the wire is there, and it is an infinite length wire. Okay, we are considering it as a infinite length wire. Now question is that find the force by ring on the wire. So what we are going to do for calculating the, see, we cannot directly apply the formula. Why? Because it is not a point charge, so we cannot apply the formula here, that is a sure. So what we have to do, we have to break it into a small element. So how to break it into a small element? What we will do, from center we will go some distance x and take a small element that is called as dx. And as it is a wire, so it will be lambda coulomb per meter, the charge density will be lambda coulomb per meter. So what is the electric field? Electric field will be a small electric field, a small value of electric field. It will be how much? For ring, because it is a ring, it will have a charge capital Q. And what is the electric field? KQX upon x square plus r square power 3 by 2. So what is KQ? Q is this thing, but here we are what we are doing, try to do, or yeah, so here we are trying to calculate the force. So what is the electric field? Because if we remember one concept, what is that concept? The concept is my electric field is equal to a small force dF by Q, that I can write. This is the concept, because we know that my E is equal to F by Q, that thing we know. So for a small element we can write like this. So if we can write like this, we can also write that my small force dF will be equal to, that is dE into Q. Now the thing is that, what is that dE? dE is the electric field due to the ring. And what is this Q? Q is the charge which is present on this wire. What is that charge? That charge. So what is my electric field? This value I will write it as integral, because when I integrate this force, then I will get the net force. So what is my d? D is k q x upon x square to the power 3 by r square to the power 3 by 2. Now what is q? Q is dq. Dq is how much? That is lambda dx. Lambda dx. Clear? Is this x is a variable or constant? It is a constant. So just you have to integrate this thing. X is a variable or constant? It is a variable because that x will vary. So this will become kq x dx, that is lambda upon x square to the power r square to the power 3 by 2, and we have to integrate this. Now if to integrate this type of integration, there is a special rule. What you have to do, you have to use substitution method for the integration of this thing. How to do the substitution here? Whatever it is given in because it will come lot of times in physics, so you have to remember whatever is the denominator, you take it as t square, then you differentiate both the side. 2x dx is equal to 2t dt. 2 will cancel out, you will get x dx is equal to t dt. So this thing you will get k q lambda integration. Now what is the limit? Limit I am not putting here right now. That will be t dt upon this thing will become t, because this is t square, square will cancel out, this will become t cube. So from here what we will get? We will get k q lambda integration of 1 by t square into dt. Now this thing we got. Now what we have to do? So we can say our net force dF will be how much? K, it is k q lambda integration of 1 by t square into dt. Now let us talk about the limit. If you see the limit, see we are taking the element, the wire is from center to infinity. So our element should go from x, from here, this is my starting point and this is the end point. So from here if I say my x value will start from where? From origin 0, and it will go up to infinity, x is equal to infinity. So from here we can say what is our limit? X equal to 0 to x equal to infinity, but we are doing the integration with respect to t. So we have to put the limit of t. So we have substituted x square plus r square is equal to t square. That is a substitution we have done. So put the value of x is equal to 0. So you will get t is equal to r when my x is equal to 0, and when my x is equal to infinity, my t is also equal to infinity. So what is the limit I will get? I will get k q lambda. This value will get 0, sorry, not 0, it is r to infinity 1 upon t square dt. So you will get the value as minus 1 upon t, and you will integrate, you will get k q lambda upon r. That is my F net. Clear? Newton. Clear? So this is how we approach this type of questions. So in this class we have seen about the 3 basic concepts. That is, first is we have seen about first we have basically seen about the constant electric field, that how to deal with the constant electric field, how to solve different types of question related to constant electric field, and then we move to the next concept, that is the calculation of electric field for the different geometries. First we have calculated the finite wire length, then we go for the different case, that is infinite wire, semi-infinite wire, and then we move to the ring, and in the ring we have calculated the electric field on the axis, center, and where we get the maxima, minima, everything. And the last thing we move to one numerical. So in the next class we are going to discuss about the disk, hollow hemisphere, and everything we will discuss, and then we will move to the potential part, and this is how we will cover our first part of electrostatics. Till now, take care, goodbye, thank you.